Hi guys, welcome to Rad Lab. I'm Ben Israeli. I'm a graduate student in the plasma physics program at Princeton, and today I'm gonna tell you guys about a hobby I have, amateur astronomy. I started like a year ago or so. I've since kind of become obsessed with it. It's what I do with a lot of my spare time. Really excited about it, so I'd like to share it with other people and hopefully get you interested too. Just gonna sort of give an intro to what you can do with some fairly basic equipment and sort of frame it in terms of the journey I've been on over the past year or so. So there we go. So this is a light pollution map of the United States, and as you can see, we're not exactly in a great place in Princeton for astronomy. I grew up on Long Island, and it's not great there either. I had not seen the Milky Way at all until like last year. Like I had barely seen a like properly dark sky in my life. So in last July, my friend was like, "Hey, want to go to a dark sky site? There's a place over in northern Pennsylvania in this little like black hole over in the top left corner here." Uh, yes, the cursor is a laser pointer. Apparently, Google Docs does do that, Cynthia. Um, but yeah, and in like this black hole over here, there's a state park called Cherry Springs State Park that has been designated an astronomy field. That there's really low light pollution in the area, and there's ordinances to keep it that way. And they've set things up to make it really easy to go do astronomy. It's like this field, like people go camp out in it, and um, that's what this over here is like. What the sky looks like at night, which like in a camera you get a lot more like this detail and a lot more color, but honestly, this isn't that far off. Like every time I go out there, I like it gets dark like remarkably quickly for some reason. Maybe it's just the lack of other light sources, but like it gets dark and you look up at like every time I'm like, I did not know there's that many stars. It gets me every time. Anyway, so yeah, we went out there, or we were gonna go out there. I was like, hey, are we bringing a telescope? And they're like, no, no one has a telescope. I'm like, okay, well, let's see, it's six of us. Can we get it? Can we put together the money for a telescope? Because like this would be cool. And we realized, and I Googled it, I realized like this guy here is a pretty good beginner telescope. You can see a lot of good stuff with it. It's $150. It, like the entry to this is like not nearly as high as I thought it'd be. I thought like optical equipment, it's like this probably won't end up working out, but it ended up being like, whoa, we can get something that'll show us some really cool stuff very easily. And I guess the fact that it's so much more accessible than I expected is like kind of what's resulted in this precipitous dive that I've taken into this hobby. That like, wow, I can do way more with this with way less than I thought. Anyway, so yeah, so we got this thing and we took it out there and we like set it up. Had our cars camped out here. There's some other people also camped out with their own telescopes. It's kind of funny. Everyone just drives out here. There's random folks from all over with different equipment. Anyway, and the views were amazing. Like this is a photo that my girlfriend took of the sky. It was beautiful out there. Um, just to like get a sense of like what we could see with that telescope. I have over on the left here like some photos that are not these are not by us, but they're from a website that sort of explains what different telescopes can do. That sort of I think these are good descriptions of what you could see with that particular scope. That like you can see Jupiter, you can see its moons. I saw Jupiter's moons. It's like I don't know. I thought that was just crazy. It's like this is what Gal this these are the four Galilean moons. These are like what Galileo saw when he first looked over at Jupiter. And you can see Saturn. You can very clearly see the rings, which I don't know, also just blew my mind first time I saw it. And you can see galaxies. Like this right here would be roughly what you'd see through that scope that I showed earlier of Andromeda. Like if you looked at the Andromeda galaxy, which is like a patch of sky, maybe the size of like your thumb or so, if you look at it through a telescope, there's like a faint fuzzy thing there, and that's an entire galaxy. and just, I don't know, it doesn't look like much through a scope, but knowing that like these photons traveled through intergalactic space to this telescope, reflected off a mirror and into my eyes, like it doesn't matter if it's not as pretty as like a Hubble photo or something. It's like there's something amazing about really seeing it with your own eyes, I think. So yeah, I can, like 3 weeks later, got this guy, which is a good deal bigger, and it yeah, it's a good deal bigger. It's like sort of like the next step up from a like absolute beginner scope. It's 8-inch aperture. That other one was 4.5-inch aperture. Just to give a sense of scale, here's how big it is relative to a banana. Um, yeah, and I should probably at this point like explain what the deal is with all these different types of telescopes and why they look like weird cylindrical things rather than maybe what you're picturing of a telescope. There's roughly three types of optical telescope. There's a refractor telescope, um, that is like, what you picture. You got a lens in the front, you got a lens in the back, and yeah, it does what like you think it does. It magnifies it, and you can get hobby scopes that look like that, and they're for things that I'm not as into. Like they're for applications that aren't what I do. What I am really interested in is looking at deep sky objects, so galaxies, nebulae, clusters, like things that are outside the solar system that are very faint. So when you're trying to look at that visually, you need to get as much light as you can to be able to see it. And so what you end up going for are reflectors, which you can get just because of how the costs and weight scaling works. You can get much bigger, much more easily with a reflector. So common reflector design, a Newtonian, is like you get the light comes in from one side, it reflects off a big collecting mirror, and then off a little secondary mirror and pops out the side to an eyepiece over here. So like this one on the right here is that first scope I was talking about. It's a little eyepiece here, um, and there's a little finder scope here, and like this isn't what I have. This is a very similar one to what I have. That some of the bigger ones you end up on these weird like turret looking mounts because it ends up being easier to work with and um, also lower cost. But yeah. Oh, quickly, like what's a finder scope? Because I just said that word. I didn't like explain that word right. So basically, when you're trying to point this at something, you need to point it very precisely. Because if you're looking at some object that's like a half a degree wide or smaller in the sky, you can't just do that by hand and expect it to show up in the eyepiece. You need to be able to like center it and then zoom in and center it better and zoom in. So you start zoomed all the way out with the smaller scope that is much wider field of view than what you can get with the bigger scope. And you start with like lowest zoom on the big scope and you zoom closer and closer. So that's why all of the big scopes have little scopes on them, because those are for sort of aligning things to start with, right? And then there's a third kind of scope, which is a catadioptric, which, yeah, that's a heck of a word, but it kind of mixes reflectors and refractors to sort of squish it as small as possible, or smaller anyway. It sort of folds the light path so you can get a really compact scope. Um, as a result, there's a trade-off in like weight, or like it's smaller, but then it's like denser, and then also it's more complicated optics, so it costs more. So that's the trade-off. In general, for the kind of stuff I do, people go with reflectors. Um, all right. Any other random thing? Right. I should probably. Um, I think I explained it. Okay. Oh, right. I have a blank slide here because that reminds me to do this, which is hello. There we go. Hopefully you guys now see a web page, and someone will tell me in the chat if you don't. That basically, like, what was I just talking about? Why did any of that matter? Like, what does this actually do for what you see in the end? And I could try to like curate some very specific slides to do that, but someone has a blog page that does much better than I can. There's a question. Let's see. Why doesn't the mirror closest to the eye in a reflector scope not block any of the image? So it does block some of the light, but effectively you don't see it because it's so close up that it's extremely out of focus. So it's kind of like how if you look through a screen window, you don't see the screen. Similarly, it's sort of in the way. You definitely lose some light, and there's some stuff about telescope design, about like the trade-off and how to make that smaller. But it doesn't. It's not a huge deal. Um, yeah. Okay, right. So like, what do you actually see with these scopes? Like, what does this difference in size mean? Why did you need what was the purpose of getting one that's like the size of your bookshelf? Um, so this website has like it call is divides things into small, medium, and large. I think it kind of overestimates each of them because I think basically it's due to the writer being more experienced and being better at picking out small details and low from very small amounts of light. But I think honestly, I would shift over all of these charts that he has here of what to expect to see with different size scopes. But whatever. Basically, with the little cheap one that I started with, this is like roughly what you can expect to see with planets. You go up to the one that I showed a picture of that I got like last summer. You sort of start to see more detail. Things are bigger, things are sharper, and then as you go up in size, things look, of course, clearer and sharper. Um, Although with planets, never mind, it's more complicated. But really, what I'm here to talk about is deep sky objects, which basically the more light you get, the more detail you get. That like you'll see some faint fuzzies in a smaller scope. In that white one that I got last summer, you start to like in galaxies, you start to see maybe a little bit of spiral structure, and nebulas start to have more detail and more contrast. And then you get up to bigger scopes, maybe like 12-inch plus aperture range, and you start to really see details and things, and basically just as you go you just get more and more detail, and that's why people upgrade, I guess. Yep. And that's like what you can expect to see. Yeah, so next chance I got after last July to go to back to Cherry Springs was September, and the reason for that is that you kind of have to time it to a particular window. That the sky is only completely like free of extraneous light when the moon is not there, as well as there being no light pollution. Um, okay, right. Cynthia's asking about price points. I was trying to avoid saying the like prices too often in this because it can quickly devolve into that with all of these different upgrades and whatnot. But basically, like the one I got last summer was 270 used or secondhand unused. It would be like twice that new. Never get any of this stuff new. Don't get any of this stuff new. You can find it way cheaper secondhand in very good condition on a classifieds website. Um, there's like specific forums for this. And then I recently got a 12-inch aperture one that's otherwise effectively the same, just bigger. Again, used for like 500. But these things like have no upper bound. There's people with like $10,000, $20,000 scopes, but that whatever. In any given hobby, there's gonna be people with like more time and money to spend on it, and there's no upper bound. But I think you can do some really incredible stuff with like keeping to the lower end of the spectrum, honestly. But yeah, so back to the moon. Um, right. So if there's a full moon, that means that the sun, the moon, the Earth, and the moon are kind of in a line. That all of the uh, bright side of the sun of the moon is facing the Earth, and you see a big glowing disk. When it's off center a little bit, you see some of it like it's cut off. There's a glitch in this thing. Anyway, um, point being, sort of as you go around to a new moon, you get less light, of course, because there's less of the glowing part of the moon visible. But also, just as importantly, if as you depending on the time of the month, the moon is in the sky for different parts of the day. Full moon, it's in the sky only at night. New moon, it's in the sky only during the day, although it's not visible because there's no light reflecting off it towards the Earth. And like first quarter or third quarter, when you can see like half of it, you either get it for half of the first half of the night or the second half of the night. So you have to aim for when the moon is a crescent, both because you get less light and because of that. So that anyway, that was too long to explain it, but that's why there's sort of windows of when you can go do this. Anyway, so I went in September, drove up all the way on my own, got there and found like 300 other people there because apparently there was a star party, which is a big convention for this. So that was kind of wild. The whole field was just full of tents and cars and telescopes. It was something. Yeah, I did this stuff all again, which like, what does this stuff mean? I guess like, what am I doing when I go up there and I set up a telescope? Um, Basically, set up the scope, get everything collimated and lined up, and then like think of things to go look at. What's in the sky at this particular time of day? Like, let's say I'm looking for the Triangulum galaxy, which is an easy enough. It's a relatively bright, large galaxy. This is what it looks like if you have really fancy astrophotography stuff going on. It's not what you're going to see through the telescope. Um, yeah. Anyway, so like this is what that section of the sky looks like to the naked eye. Like there's the horizon. This is like sort of a third way up the sky in this particular image. So you get the scope aimed roughly in that direction, and now you want to sort of like guide your way there. So this zoomed in thing is what you'd see through the finder scope. It's like 6 or 7 degree field of view. So you can kind of see this the triangulum, which is this constellation over here, that hence the name Triangulum Galaxy. Anyway, so that's the big bright thing you kind of aim at with the finder scope. And now you're looking through and you can kind of figure, okay, so I'm going to be more zoomed in through the telescope. It's going to be like a 1 degree field of view. So like, what can I hop to? I can hop from this guy to this guy because I can see maybe them both at the same time. And then this guy to this guy, this guy to this guy. There's this big jump, which has given me this particular jump has given me grief previously. Anyway, you sort of have to hop your way there. And it's kind of difficult because when you're looking through the telescope itself, this is how zoomed in you are. Like these stars here don't even show up on this image here. Like they're just in here. So there's sort of this like weird guessing game of like working your way up, which is a lot of like, what am I doing during it? I'm the star hopping, which anyway. So once I get to a thing that I'm looking at, if it's something sufficiently interesting, I'll try to sketch it because I don't have astrophotography equipment. That stuff is like, I think baseline like $2,000 or something to get into that, and like it's a whole like you're in front of your computer, you're not in front of your telescope, so it doesn't appeal to me as much. Um, but yeah, so I can't get pretty images like this one on the right. But if I'm looking at the Orion Nebula, which is a nebula, it's like it's part of the sword of the Orion constellation. It's like there's like a fuzzy spot there. If you have good skies, you can kind of almost make it out actually. Anyway, so if I'll point at it and I'll try to sketch it with pencil and paper. And this is a scan of a sketch I took that September. It's inverted, so I white is black, black is white now, so it looks like stars because this was done with pencil. And yeah, um, I'll spend like an hour or so pointing at a given thing, like trying to getting all the stars in place and then getting shading and details. And it's weird because you look at it, you get the image of it, and then it's like by the time you finish sketching it, it's moved out of view because the sky is moving as the Earth rotates. Thanks, Cynthia. Um, uh, yeah, as the Earth rotates, it like moves out of view. So you have to like continuously readjust, and it's this like very absorbing activity of continuously adjusting, looking through the thing, looking back at the paper, and I find like that whole process just very relaxing because there's no space for other thoughts. It's just this process, and I don't know. I think the things that you get to see while doing it are just really beautiful. So I enjoy it. And yeah, so here's some other sketches. Oh, actually, the same sketch again, but just as an illustration. These are the same two. These are both the same object. One being sketched from Long Island, one from Cherry Springs. Different field of view. Like you can see that like this circle here is this circle here. This is the same equipment otherwise. So you can see like how much is lost due to light pollution. That like there's a huge difference depending on your location. But you can still do some pretty fun stuff in light polluted areas anyway. That's what I do when I'm not driving to rural Pennsylvania. And yeah, this is my sketching equipment. It's pretty bare bones: pencil, smudgy thingy, eraser, stencil to make the eraser focused on particular points, notebook, sandpaper for the smudge thing. Yeah. And then an entirely separate project. We're not going to do a good segue here. Uh, you might have seen in the news in like last November that there's like a transit of Mercury that basically Mercury lined up exactly in the line between the Earth and the Sun, so that from Earth it appeared as a dot in front of the Sun. And that was really exciting because like that's a thing that doesn't happen very often at all. And this happened just as I was getting really into this stuff, so that was like really cool, really good timing. Um, and I immediately scrambled to figure out like what equipment do I need. And like, okay, so the telescope is exactly what I need for this, but I need a solar filter because you cannot point a telescope directly at the sun. Um, I need to like give the warning, please do not point telescopes at the sun. That will irreversibly damage your eye. But if you put a thing in front of it that's kind of like the film that's in the, you know, like the eclipse glasses that everyone had in, what was that, 2017? Yeah, like that kind of film, if you put it in front of the telescope, you can look at the sun and you can see Mercury as a little dot on the orb of the sun. This is literally a picture taken with my cell phone because the like camera adapter I was trying to get didn't come in time. But anyway, um, you can see that like there's Mercury, which is in front of the sun, and I don't know. I thought that was a fun project. Not gonna get to do that again for a long time. And yeah, this is the setup I was using. There's me set up in the early morning before running to class. And there's the filter thing I built. A little bit of film in front on the front of it, just a piece of plywood, with it sandwiched in between. This filter thing that I built was actually made at the Studio Lab. Um, like it, I just have to pitch that the Studio Lab has a wonderful laser cutter that you should all go check out when campus isn't closed. Anyway, so yeah, I just cut out some layers of plywood sandwiched in between, used their metal cutty tool thing to make a nice swiveling lid for it. So that was cool. Very happy with how that turned out. Cynthia has a question. There's somewhere in the U.S. that I'd like to travel out just for astronomy purposes. So basically, if you look at that map, if you Google light pollution map, it's the first link. You can see that you can see that like in the north in the entire like east basically there's very few spots that are completely black. Even that dark sky site isn't perfect. There's like a spot in like West Virginia and part of the Adirondacks, I think, that are totally dark as far as you can see on that map. But if you go west, it's like a huge fraction of the west is like really good skies. It's actually kind of hilarious. Like everyone on the forums is from like Arizona because it's so much easier to do this in Arizona. So I don't know. I guess I'd like to go basically anywhere that's not here to go do this. I'd really like to go somewhere in the southern hemisphere, actually, though. If we're going outside the U.S., I'd like to go to the southern hemisphere because you can see things you can't see up here. I'd really like that. Yeah. Anyway, cool. So another totally random project that isn't technically astronomy, but I thought was exciting was I realized that it's actually feasible to photograph the International Space Station using the equipment I have. The way I realized this is I saw a video by Scott Manley. I don't know, guy on YouTube. You might have heard of him if you're the kind of person who watches space videos, which maybe you are because you're watching this. Um, he, I'm pretty sure he got a reasonable shot of like you could kind of make out the space station clearly using just a DSLR and like a pretty good zoom lens. He's just kind of holding it and tracking it by hand. Oh, right. By the way, you can see the International Space Station pass overhead like fairly frequently. If you go online, you can find schedules of when it will pass over your particular location, and it's just this like really bright moving dot going across the sky, which is kind of wild. Cause it's like, dang, there's like 5 people on that right now, and it's in space anyway. Um, so yeah, I saw Scott Manley do it with a telescope, with like a DSLR. I was like, maybe I could do this with this telescope, and I did the math. The ISS is like 100 meters wide. It's like 400 kilometers up. So it should be like 0.014 degrees wide, 51 seconds. Second is a 60th of a minute. Minute is a 60th of a degree. So yeah, it should be like small but doable. And it's moving at a degree a second across the sky. So I need to track it pretty quickly. I did a little math, made a nice spreadsheet of all my of like the equipment I was using, like this adapter, the eyepieces, etc. I figured out I could get a quarter of a degree wide field of view, and that as a result, on my girlfriend's DSLR, the ISS would show up as 270 pixels wide. So basically, I figured out that I could I could like that I would be able to get it zoomed in enough that it would be visible, like as several hundred pixels, so it'd be pixelated but clear enough, but zoomed out enough that I'd be able to reasonably expect to keep it on target. And keeping on target was hard because if you just kind of leave the telescope pointed at one spot and let the ISS cross the field of view, it'll cross the field of view in like a quarter of a second, and it'll like cross a length equal to itself in a 70th of a second. So you need a very high frame rate for taking this picture to have it not be blurry. I think I ended up going with it's like a 250th of a second. I don't do much photography, so I don't actually know if it's that high. But anyway, there's some math to be done of on that. If anyone would like to hear about the details of this and look at the spreadsheet, you can talk to me later, but I assume not. Yeah, so I figured out it can be done if I like manually look through the finder scope, keep it dead centered in the finder scope, and have the camera just continuously taking pictures. And like I got like a few hundred pictures over the course of 4 minutes. This is my fourth attempt. I made several really dumb technical glitches on the previous 3 attempts. It's also at like 4 a.m. each time, which was an adventure. Um, anyway, of those 400 shots that I got, like 3 or 4 of them ended up being really particularly clear, and these are the 3 best ones. So you can see that they're all at different angles because they're at different spots in the sky. So you're looking at the ISS from different angles. You can clearly see like here's the solar panels, here's the other solar panels, here's the main like axis of this station. You can see that there's some modules sticky out from the middle. I don't know. I was pretty pleased with how this turned out. I think I can do better though. I think if I like choose different eyepieces and like tune the camera settings. I also got a bigger telescope, so maybe it might help. Um, anyway, oh, Cynthia's saying 4 a.m. is definitely an adventure. The best part is I was waking up my girlfriend to do this every single time. She's a trooper. Anyway, so um, yeah. So I'm gonna probably go back to this project at some point because I think I can do a little better. And oh yeah, right. So I mentioned I got a bigger telescope. So a few weeks ago, I got this gigantic thing, which there it is, scale. This is what it looks like if I hold it, just for a sense of scale. There's the same banana from earlier for scale as well. Um, it's 12-inch aperture. It's basically otherwise exactly the same as my other one, and I'm very excited to get using it again this October when I go back to Cherry Springs. And then I also got this guy, which was for an aborted plan to go to rural Canada with my family. Did not happen because pandemic. But this guy can fit in. This is the biggest one you can get that'll fit in a carry-on bag. So we'd be able to like bring it up in our like everything else in the suitcase, this thing in the carry-on bag, and actually be able to bring it with us on this like family trip that we were doing for separate reasons. And I don't know. It's nice because I now have this little guy that's easy to carry, and it's pretty good for photographing planets and the moon. You can't do deep sky objects because you need tracking to do deep sky objects, but that's been fun. Um, yeah, and yeah, I've been going back to Cherry Springs every time I get the chance. Like I was there in July when you probably saw in the news everyone was talking about Comet Neowise, which still bugs me a little bit because the instrument used to find it was called Neowise. The Comet had some deck that does it anyway. But yeah, so this is what it looked like through a like few second exposure with a regular camera. Again, credit to my girlfriend for this one. And through a telescope, it looked amazing, and it was just very exciting that there happened to be a new moon right when this thing was like well positioned in the sky. And I got a sketch of it that I'm pretty happy with that I'll show later. And yeah, so that was awesome. And I went back again later in the summer, just like for reference. Like this is what my setup looked like when I went in August, for example. This is what it looks like when I set up. There's the telescope. There's the other little telescope. There's like various gear, sketching bag, eyepiece stuff, dew heating stuff, little chair that I made and determined I'm bad at carpentry. There's my friend who made an entire like fancy Italian pasta dish for breakfast. It was something, little gas stove. Yeah, and yeah, I kept making sketches. So there's the comet I mentioned. Um, Pretty happy with how this one turned out. I think I screwed up the shading right here. I kept having to like correct things. So I eventually had to like just leave it because it was starting to get impossible to correct it better. But I think its shading turned out okay. There's the little Dumbbell Nebula, which I also got in August. That one was fun. It was an interesting one to try to find. Right, and then when I went this past September, I had the new scope. So this is just for comparison, like how much just 4 inches in aperture and a new oxygen 3 filter can do. That like with a slight change in equipment, I got like some really amazing views of a lot of details. Like this is the same thing I was sketching earlier, but like zoomed out. Like that was what I was talking about from last year, being pretty happy with. That was zoomed in here, and then this is zoomed out further and with more detail, which I'm not sure how much to credit that to the oxygen 3 filter, which basically filters out everything but emission lines that happen to come from a lot of nebulas, and therefore like really improve the contrast of nebulas, or how much to attribute it to the bigger telescope. But I was very excited when I got this sketch because very excited when I looked through the scope in the first place. Like, oh my god, there's so much more to see here. Um, I was, I don't know. I found it really exciting. I think that's like basically all I've got. I have like I could say some more about some random other like side projects that this has resulted in, like, but that's like as much of the astronomy stuff that I can talk about. So let's see. Michael has a question. Do you like or not like to go back later and compare your sketches to pro astrophotographs? So I don't even try to compare it to astrophotography people stuff. If you go just Google astrophotography, there's some amazing stuff that like people who are totally amateurs can like get incredibly beautiful photos, but that involves like much fancier equipment and involves like a lot of image processing. It's I've deliberately made everything I work with not electronic in this process. Like I don't even use a tablet anymore. I have like actual paper atlases because I want to keep it simple. So I can't expect to get anything like what they get. But I do compare to other people's sketches, and yeah, other people are better at this than me. I'm not very good at this, but I do have fun. Um, and I do compare it to like I guess professional photographs just to see how was I close? Did I mess up? Is what I saw what is actually there? Actually, I could have sworn I saw spiral arms in the Triangulum Galaxy last time I was there, and all my friends were like, "I don't see anything. What are you talking about?" I'm like, no, they're there. And I like looked up the shape of it later. I was like, no, I totally saw it. Totally got it right. I was very pleased with myself. Um, it's actually I think there is an element of just practice and finding finer details in faint objects. Um, yeah. Yeah. So yeah. Anyone have any other questions? Cool. I guess if you have any other questions, I'll be hanging out on the Slack channel for a little while. And yeah, thanks for tuning in to Rad Lab.